A very good morning to everybody from Shala, Slovakia. My name is Peter Hrubina. I'm export manager of Microwell. We develop and manufacture swimming pool heat pumps and swimming pool dehumidifiers, and currently are selling to more than 35 countries worldwide. Today, we have approximately 40-minute presentation about tips and tricks for pool heat pump installation. It's a webinar through which I can see that almost everybody from the registered attendees are already in. I have messages that you can hear me well and that you can see me well. So I will start right on. You can send your questions in down below bottom right corner. There is a chat or Q&A session. I already see several questions from yourself, and thank you, Gancho and Adi, for checking my sound. So I can start right here. We received many questions from installers at this summertime period about swimming pool heat pumps, and we decided to address them via webinar. So you can get more broader information at one place. First is very basic description of heat pump. We can talk naturally 2 hours about this and still not be not fully cover the topic. Is basically a pool heat pump. I'll try to make a pointer. Pool heat pump is a system that extracts heat from surroundings with usage of the fans, and then through the compressors, it pushes this heat into the water. If we talk about cooling, this is the vice versa process, which means you are taking the heat from water and releasing the heat to the air. Heat pump is in principle a simple machine that consists mainly of compressor, air and water heat exchanger, and ventilators that run the air through them, and of course then the control box. Important question is about the installation that we received many times. Actually, this whole webinar will be purely focused on practical things. So we are going to focus on installation, on the actual examples from the installations, and we try to build the presentation to fit on the questions received during the registration process, because you had also the ability to give us questions during the registration. So we have made it in a way trying to address it directly here. One of the basic questions is the actual position of the heat pump. Here, generally 2 points. First, you should realize that the heat pump's main power or capacity source isn't the electricity, but it's actually the surrounding air. And if you block the surrounding air by any means of tree, building, fence, or anything else, your heat pump is going to suffer, and your capacity and efficiency measured by COP is going to suffer. So important thing is to maintain certain distances from around the heat pump. And if it's a winter use heat pump, then also the pump should be at least 30 centimeters above ground to protect it from snow and allow free condensate drainage. This is an example of a winter application of a whole year swimming pool heat pump. As you can see, it's incorrect because the heat pump generally sits on the ground. So as soon as the snow hits, the pump will be submerged into it, and it will have no option of defreezing itself. So again, you need to position the heat pump on certain stand. This is, on the other hand, a correct installation of a whole year also introduced heat pump. As you can see, the concrete blocks, and on the top of them are the rubber vibration absorbing base or blocks, and on top of those is the heat pump. So the heat pump has a very low probability in being submerged in snow, and also it has a very good condensate drain ability. Another example of heat pump for winter use in not really correct way of installation. What the installer tried to do was to hide the heat pump somewhere. He did not really put it in a place where the heat pump can have a free air supply, so it's blocked on the air supply line. And the second problem is that the heat pump is positioned directly on the ground, so during the winter time it will freeze and it will have no possibility of defreezing itself. This is a very nice example. We have installation in Germany. It's an outdoor pool with a 327.5 kilowatt machines. As you can see, it's a split machines. Some things were done correctly, but there are certain things which were not. One of them is the distance between the units. This is very little. So especially the unit in the middle will suffer because it will not have the sufficient air supply that it needs. And secondly, you can see on the right picture, the units are not water leveled. So the units are actually bending forward a little bit. And if this happens, then during the defreeze cycle, the defrost ice will, or the water created will gather in the front parts of the heat pump, which will continuously create icing of the heat pump. This is example from a also whole year used pool. As you can see, there is a dry 1200 metal dehumidifier inside the cubicle, and on the outside there's older heat pump of ours, on-off type, 28 kilowatt. But what's important here is this little diffuser marked in red, which was installed by the client in order to somehow guide the exhaust air in certain direction. As you can see, it's a pretty small piece of metal, but our measurements showed that it actually decreases the COP by almost 20%. So in other words, you put this kind of a metal on the heat pump and your energy bill or bill for electricity will increase by 20%. These are a few pictures from correct installations, especially the central one that is from Norway, the stand made of wood. Again, there are really no limits in terms of how the stand looks like. Important is to keep it above ground if this is a whole year machine. Looking at the picture at the left, you can say that the heat pump is pretty close to the wall. It is, but on the other hand, it's well above ground, so the air can really flow from all direction to the heat pump from the back. So it's also okay for the heat pump to be installed in this way. This is installation from Bulgaria, company Aquatec, if I'm not wrong, and we have them today here also on the webinar. This is a very nice installation. Everything that you have to mind during the installation was kept in here, and we really have no comments on this. This is a very correct installation, how it should be done, the space between the units, above ground installation space from the building, etc. This is the installation of two 35 kilowatt split heat pumps in Germany, if I'm not wrong. On the left side, you can see the before picture, and on the right side, you can see the after picture. There were several issues. Mostly the heat pumps were on the ground. Then you can see the third center red arrow. The heat pumps or the exhaust air was hitting the bottom concrete part of the fence, which means the cold air was being reflected back. And there were other issues with the very, very tight copper piping and other matters. So it was solved on the right side, as you can see on the stand, the copper pipes and everything, and the system works just fine. This is installation, I think, from Hungary. Sometimes we do see installations like these. Honestly, we don't much like them because, as you know, when the heat pump heats the pool on the exhaust from the heat pump, since it took heat from the air, then the air on the exhaust is colder. In this case, much colder. It could be 10, 15 degrees colder. So if you have 28 degrees, 30 degrees summer day, the air on the exhaust will be 15 degrees, which on one way from one point of view isn't really comfortable to feel, right, when you have a blow on your neck. And from the second perspective, the cold air also increases the heat loss from the pool. So you will have to heat the pool more or in higher excess that you potentially wanted to. This is a current picture of the HP Black installations, one of the machines that also I've got here behind me, the seasonal inverter machines. It's on the roof. Why we marked that the installation isn't really correct is because the pump sits on a concrete blocks. Even though it's inverter, even though it's all insulated and everything, I still would suggest to put it on a rubber base when it goes on the roof of the building, so the vibrations are minimized. But what we don't specifically like is the water piping, which, as you can see, has not been insulated. So it's just a pure water piping. Imagine a summer night or autumn night of 10 degrees ambient, and you have a 30 degrees water flowing in non-insulated water tubes. Also, what pays off to mention is the actual insulation of the pipes and the roof. This is done with silicone or something, which isn't gonna hold for a long time against the rain and snow, but this is just the point. It's completely off. The heat pump, normally you should do it with a plastic piping to 45 degrees. This is another installation of a black inverter machine, which is correct installation because there's a rubber in between the concrete and the pump, and the space underneath the pump is empty, so the pump has enough space to drain water from defrost cycle during spring and autumn nights if the pump freezes up. This is installation, I think, from Czech Republic, and this is installation of two compact machines, 17 kilowatt, 21 kilowatt, 17 kilowatt, I think. So 34 kilowatt altogether. Now they have done many things right, and many things we like. For example, the stand of the machines, since this is a whole year application, the machines have really free supply of air. There's a space between them, a sufficient space. They have a really, well, unlimited word. Unlimited isn't really a good word here or the appropriate one, but they have really a good space to drain the water during the freeze cycle. Also, if it's snowing, they have very little probability of being submerged into snow. As you can see from the right part of the picture, the water piping is well insulated. So many things they have done right and really perfect. My personal suggestion would be in these kind of installations, I prefer seeing split machine. So you don't really have control over the power supply availability. And in the case you don't have your own battery solar grid system, if the power supply goes off for half day during winter when it's sub-zero ambient temperature, that means your circulation pumps are going to be off, and that means you may potentially run into trouble in terms of water pipe freezing or exchanger freezing. So I would prefer seeing split this kind of application, but again, looking at what they have done many, many things right. This is a example of 28 kilowatt Inventor machine, HP 2800, which is connected, it's a compact machine, monoblock machine, and is connected with a technical room with water pipes. Important here is that the water pipes are insulated. So, and this is a very good example of the insulation and how it was done. Again, very good job. You need to remember that the ground has a stable temperature, and if you like to heat up to 30 degrees or 28 or 35 or whatever, and you are guiding your water piping through the ground, it should always be insulated to avoid additional heat losses on hydraulic way in between the connection of the heat pump and a pool technical room. This is from the other perspective, an installation of a system. This is in Saudi Arabia, and this was a 17 kilowatt machine in cold tap application, so cooling water to below 10 degrees. And as you can see, it's installed outside because of a space matters. They didn't have space to install it inside, and the pipes are not insulated. So on the left side picture, you can see that we took this with an infrared camera. It was a summer peak day, and temperature of the water pipes was almost 55 degrees. And you don't need to be a rocket scientist to figure out that the pump is really suffering enormous heat gains on the way, which the pump must compensate with cooling before it can cool the actual tank that it was designed to cool. So again, add insulation in these kind of applications. Right. Many questions, and I need to say the most questions that we received during the registration process, and also that's the same case with this webinar that we did 2 weeks ago in Slovak language for Slovakia and Czech Republic. Most questions came about the water flow and the flow switch and the flow switch error and the bypass valves and all these things. So we prepared several slides about this topic. First of all, this is a picture of bypass valves where at the bottom, imagine a heat pump in and out, and at the top from right to left, you have a filtration circuit from the right from the pool to the left to the pool or to water treatment, chlorine, salt, whatever you are having. So this is a basic setup that you would like to see with every single heat pump that enables you to bypass the pump if you need to regulate the water flow, which is very important for a heat pump operations, especially the COP. And in general, it gives you much more flexibility in maintenance. This is a picture of a 6-way filtration and also the pressure bar, the normal, because this is a very common question, what is the maximum water pressure of the system? Well, the heat pumps are made for 5 bar water pressure. We do make tests for 10 bar, but this is a several minute test and it must pass several minutes, like 2 or 3 minutes in 10 bar, but it must maintain or it must work in long term in 5 bar. The normal standard, or let's say the general pressure in the pool filtration circuit is, however, under 1 bar. So you're looking at 0.8, 0.9 or 1. Of course, if the 6-way filter isn't set up well, or if it's dirty, you can have peaks in water pressure, and that's why we do make very, very rigorous testing for 5 bar just to withstand any pressure peaks. Yes, question for the filtration in terms of ratio between the flow in cubic meters an hour and the actual vertical height or the length. Well, again, you don't need to be a rocket scientist to understand the circuit and to understand that heat pump or the whole filtration circuit, every single part of it, every single bend, every single knee, every single valve represents a so-called pressure drop, which means a obstacle in system that a circulation pump needs to push through. So in general, if you are taking heat pump into the system, you are increasing the pressure drop by 0.15 bar maximum. It's around 10 to 15 kilopascal. So this is very little for a heat pump. It has a minimum 50 millimeter connection water piping, which then increases up to 110 millimeters at the big ones. So the heat pump doesn't really play a role when it comes to a pressure drop in a system. What you should be doing at the actual installation, or if you are not making the pool, you are only supplying the heat pump, you should make sure that the hydraulic system is really well designed for the pool itself. And when I say the well designed, it means it also must be in some sort over designed, overestimated to, again, battle with dirty filter or some kind of unexpected obstacle in the system. So again, just keep in mind the ratio between the cubic meters and the height and the pressure drop. Once again, the heat pumps are between 10 to 15 kilopascals. Okay, let's move on. This is a very important question. We prepared this little slide for it. Question was why the water flow is so important, why there is always a water flow stated in the swimming pool heat pump nameplate, and why we pay so much attention to it when setting up the bypass valves. Because with the bypass valves, you can actually set up the amount of water that flows through the heat pump. You can increase it or decrease it. You can play with it. And why it is important. A swimming pool heat pump, unlike house heat pump, works on a relatively small difference between the water in and water out. So we talk about 1 degree, 2 degrees maximum. If you look at a standard house heat pump, that works 5 degrees, 8 degrees, even more. If you look at the gas boiler, if you look at the solar, if you look at the electrical heater, all those systems work with much higher difference between in and out. So the heat pump efficiency, as you can see on this graph, this is actually, this is a 1500 black. machine. This is exactly 1500 black behind me. So that is optimized for 4.4 cubic meters an hour. And as you can see by those 4.4 cubic meters an hour, it actually achieves the highest kilowatts in heating output. Means potentially it also achieves highest COP. In other words, at this point of 4.4, it will give you the cheapest heating for your pool. And how to set it up correctly? Well, first of all, on the old on-off pumps, you gotta turn the system on and wait from 5 to 10 minutes until the system stabilizes and really the pressures from compressors start to work at 100%. And then in the summer, you should set the bypass valves to achieve the difference between in and out of 1 to 2 degrees. In winter, it's less than 1 degree. Inverter heat pumps, it's a bit different because inverter heat pumps allow you to use different modes. So you need to first of all pay attention that you set the actual max mode or boost mode or whatever you might want to call it. Then you again wait the time between 7 to 10 minutes and you try to achieve 1 to 1.5 in summer, not more. Inverter heat pumps also have the decimals in temperature, so you can actually set it up more precisely. In winter, you're looking at a difference 0.5 to 1 degree. If you are hitting anywhere above 2 degrees in any given time, let's say 2.5, 3, etc., then your water flow is too low and you are hitting the left part of the graph. So your kilowatts and COP are decreasing. Again, if you are using anywhere below 0.5, I saw such installations where the flow was just massive, was 15 cubic meters an hour, 20 cubic meters an hour for a small heat pump. Then you are going to the right spectrum of the graph. Again, your kilowatts and COP are decreasing. So this is very important setup that you can make. Of course, the customer, unless the pump isn't really incorrectly selected, the customer isn't going to notice that the pump isn't working at 100% efficiency, probably after the energy bill comes in, but until that, he's not going to notice. This is something you will not get an alarm about, or you will not get any error message. This is something you just simply should know and apply during the installation or maintenance or service. Connection scheme. Yes, a question scheme where exactly to connect the heat pump, if it's before filter or after filter or before the water treatment or after. Always install the heat pump after the filter so the water is clean, and always install the heat pump before the water treatment. So excessive amounts of chlorine or salt or whatever you're using do not enter the heat pump exchanger, even though it's made from titanium. But you shouldn't really tick on it. Yes, correct flow switch position. Again, very interesting questions about when you are changing the flow switch, how to put it, where to put it. Well, this is several pictures about that. Flow switch is general at paddle, so it's a very simple principle where a paddle with the water pressure, the pedal moves or the pedal doesn't move. So in the case the pedal moves, the electrical contact is closed. So it gives the signal to PCB that there is flow, you can work. And if the pedal isn't pushed by water, then the electrical circuit is open, which gives signal to PCB. You can't work. And every single heat pump has a pre-programmed error message for this: E3, PL, EE5, whatever comes in hand, whatever comes in there. So When you are changing the flow switch, always try to make sure this little arrow on it. Every single flow switch has on its body this little arrow, this picture number 2, and it shows you in which direction actually the water flow should be guided. And maybe I will just jump to picture number 4 and 6. So this is the actual pedal position. Again, you don't need to be a rocket scientist to understand this. So don't install the pedal like this, but install the pedal like that, so the water can actually push it. So it's nothing complex. My advice is, if you are changing the flow switch, always change it as it was. Just take a picture before you pull it out, so you put it in the exactly same position as it was before. We get many questions when we get a flow error, what to do. If you got a flow error, E3, E5, PL, whatever, that simply your filtration is working, your heat pump has power supply, your display is alive and seems to work, and it gives you some sort of error message which you find in the manual that corresponds to a flow error. First of all, you should check there is water flow. So try to play with bypass. Okay, open it up. I mean, close the bypass and let the full water flow run through the heat pump, so you make sure there is enough water flow. Second, try to air bleed the system. If there are air bubbles around the pedal, then the pedal will move or will not be stable from the water flow. We call it cavitation. It will just move very quickly, and these quick moves may cause a situation which PCB then evaluates as no flow, because it has a very quick changes between the contact and no contact. So PCB then evaluates that as a problem. So only after you check the flow and you air bled the system, you can go on and try to see the flow switch itself. It's a simple contact, as you can see, and if you move the pedal in one position, you should hear the alarm, means contact closed, and the other position not. So if you confirm there isn't any contact in any position, then you conclude that the water flow switch is broken. Otherwise, then look for the wire between the flow switch and the PCB. What you need to demount when you're accessing the flow switch, again, this is from the HP Black system. Yes, unfortunately, you need to demount this left part, which also has the water connection. So you need to disconnect the pump from water, and only after that you can access the flow switch by removing the top cap of the heat pump and the right part I mean, from this perspective, left part of the heat pump. It's when you're looking from the back, it's left. When you're looking from the front, it's the right one. The flow switch is in the central picture from the top in this blue heat exchanger, and it is connected via a male-female connector that you can see on the right side. Questions about multiple heat pump connections and the bypasses and everything else. These are pictures from split systems that you can see. Split systems, all of them have valves in, valves out, and the main bypass valve. So again, do spare some change on the valves and always create the circuit of bypass. This again allows you to do a lot of things during maintenance. And other pictures of split heat pumps, again, you can see the valves in, out, and bypass. We have got some questions about parallel connection of the heat pumps. Again, or I mean parallel connection, multiple connection of heat pumps or more heat pumps in one application than one. There are few rules, always in parallel. Never do it in series, because if you do it in series, then the heat pump second in line and third in line, fourth in line, etc. Has on the intake higher water temperature, which means lower kilowatts, lower COP. If you do it in parallel, so all heat pumps connected at the same spot, then all heat pumps will run pretty much at the same kilowatts and same COP. There are several pictures about this that we have made. You can see on the left side there are 28 kilowatt machines in monoblock. On the right side there are 4. You can see also on the right picture there's a QMax machine which we use for optimization of water flow that has a 1,000 euro water flow meter, so you can actually really precisely set the water flow and maximize the COP. That's another picture of compact machines in multiple application. So again, always do it in parallel connection. Question 2, active regulation of the filtration. Every single heat pump that we do has contact to regulate circulation pump. We strongly encourage you to use this contact simply because when your client wants certain water temperature, if it's 10 degrees, if it's 30 degrees, 40 degrees, whatever, it's good for the heat pump to turn itself on when it needs to. So it's not dependent on the filtration time itself. So once you conclude you connect it, and you will regulate it through the heat pump as well and through the clock or whatever Modbus, whatever you want to use. Always try to use the contactor as you can see on this picture. So don't, or try to avoid a direct connection. The PCB of the pump usually has 5 amp fuse. But you need to remember that even though your circulation pump is 2.5 amps or something, it's still inductive engine in there, so it can have a peak and it can burn the fuse. So always use contactor. Technically, this is how the connection looks like. In this case, it's 1 and 2. It could be P1, P2, whatever. And you find it really next to the main power supply for the heat pump. Positions of the sensors, again, several questions arrived for this. How do we find the sensor? Where can we find it? How to access it, etc. Well, every heat pump has several sensors. Generally, it's around 6. In the newest pumps, it's more. And in the new R290 propane-based pumps, it will be considerably more. Again, just follow common sense, because every pump has the actual position at different spots. So just follow common sense. Okay, wait, where I have a water connection, somewhere there will be water in and out. Where I have compressor, somewhere there will be compressor, discharge, and suction, etc., etc., etc. So it's not rocket science. Census questions. Yes, this was important. How to to identify that the sensor is broken or is correct. Well, we use NTC sensors, NTC thermistors in the heat pumps, made of copper, and they are always calibrated to 25 degrees. So in most cases, you are having a 5 kilo ohm sensor on water and 50 kilo ohm sensor on compressor. That means that you're going to measure around 5,000 ohms or 5K ohms in temperature of the sensor 25 degrees. When you are measuring the sensor, look for the 20 kilo ohm range, and then you can also Google the table where you simply put a 5 kilo ohm NTC thermistor table, and you will get something like this. Or you can send me a query and I will send you information what resistance you should measure. Remote diagnosis, yes, this is a topic that we have been focusing on for some years, and we're still working on it, trying to really make it as best as possible. Every single heat pump, and from 2025 also every single dehumidifier that comes out from Microwell will have a self-diagnosis system. Means you can go on site, or your customer can go on site, or if the pump is connected to Wi-Fi, we can read it out via Wi-Fi. Every heat pump has several parameters that it measures on constant base, and according to these parameters, you can say if the pump is working well or not. I prepared a little table to show you what actually do we see based on the numbers. So think of really a diagnosis without tools. You're looking at the numbers, and with 95% accuracy, you can conclude what is wrong only based on these numbers. You don't need any tools, any measurements, etc. So if you're looking at the table, look for the a low water flow, and you can beautifully see that if you remember the difference between the water in and out, the ideal difference that I said before is supposed to be between 1 to 2 degrees. 2 degrees is maximum. And in this case, low water flow, you can see that the water in is 29 and water out is 33, so it's 4 degrees. That clearly indicates you that the water flow is low. Every other data of the heat pump are correct, which means heat pump is working fine. It only does not achieve the kilowatt efficiency and COP efficiency that you can actually get out from the heat pump. If you have a gas leakage, this is unfortunately something that happens once or twice per year. Uh, there are several factors. You can see compressor is running too high. It's 96 degrees, while on the left it's only 75 at the very same conditions. And this is simply because there isn't enough gas in the system to cool the compressor down. Also, you can see the evaporator temperature is 18. Again, it means there isn't enough gas in the system. So the evaporator is heated up, or is being heated up from the surrounding air, and your water in and out is 29 and 29, so your pump isn't giving you much of heat. Of course, it can't because it doesn't have the medium inside it. If you have a dirty Goldfin evaporator, that's the back part, the fin air exchanger. Again, you would experience a very high compressor temperature because the whole system is overheated. But still, the water temperature on the output is 32. So you would still get some performance from the heat pump because it's overheated. It would be more. And the part of the table on the right side is the unit overheating. This is what you normally would experience in a standard issued heat pump if you apply it for extreme cooling, like 40 degrees ambient outside, water is 35, and you plug the heat pump in. You can see that the suction temperature is very high, compressor temperature is very high. So in this case, you need to lower the water flow to pure minimum to achieve the water temperature on the output, let's say in difference 10 degrees. So you would have not 27, but 20. And in such case, the suction would also decrease and it would cool the compressor down. Of course, the machines that we do for Middle East, we have here folks today from Qatar and Saudi. So if specifically talking about the machines that we export to you in Middle East, they have also injection cooling, which is extra measure to cool the compressor in this case, and some other measures such as bigger evaporator, etc. So your machines are adjusted from the factory already to cope with this extreme cooling. But that's not the case for the machines that we use in Europe, of course, because this adjustment is not cheap. Remote diagnosis, we are slowly getting to the end of the presentation. I have got maybe 7 more slides already. I have some questions in a Q&A. So I'll get to the questions right after. Heat pump black, just right behind me. That's the heat pump where we started to do the remote diagnosis or so-called IoT console. So as soon as the heat pump connects to the internet, we can see it, and we can see actually 90 days back, 90 days back of the heat pump of every single parameter we can measure. And we don't measure just the parameters you saw on this slide, but we go much deeper. We measure the hertz of the compressor, current, all sorts of things that you can really measure. And with this tool, we can perfectly diagnose the heat pump and see if it's something wrong with the installation or wrong with the heat pump, etc. So this tool on black comes again with every machine. As soon as you connect it to Wi-Fi, we see the machine, and beautifully, if you get a problem, you don't necessarily need to send a guy to site. You can just call us, and we can resolve the problem and look at what the problem is. At this moment, we last season already, we started to allow our distributors to have access to this IoT console. Technically, we can allow anybody to have access, but since you can actually adjust the heat pump, not only from the heating, cooling, and requested water temperature level, but you can adjust it from the hertz perspective, fan speed, expansion valve, all these things. We're trying to limit it to a certain number of heat pumps. I think it's something like 40 or 50 PCs per year sold. And in such case, we give you access to IoT console. You can check your machines yourself. But feel free to ask me after the session about that if you need to. So final word from my side: if you ever have a question about the heat pump or run into a trouble, or your customer calls you that something isn't right, please the first step, don't have a mindset that okay, I need to send somebody in there. No, please try to get the parameters, or if it's black inverter, call us. We can have a look at the machine and try to give us the serial number. So you can do this by your phone remotely. You don't need to travel anywhere, and you save minimum one service visit. And it's much easier, much more effective to do a first initial diagnosis of the system. All right, I'm hitting really the last slides of the presentations. Some questions arrived about the winter setup of the machines to allow heating, or to achieve maximum heating while keeping the pump with ability to defreeze itself. As you know, under around 12, 13 degrees of air temperature ambient, when your pump is in heating mode, it will freeze up. This is a natural process of the heat pump because the evaporating temperature of the gas on the evaporator side is already sub-zero, so it actually gathers water and transforms it into ice. So the pump must defreeze itself from time to time. And those are the system settings that you can apply. There are generally 4 settings that are inside the machine that has a direct effect on a defrost cycle. And in general, you are moving with changing of these settings, you are moving between the maximum heating to maximum defrosting, right? So if you are at the maximum defrosting, then your heating is very low, but the pump will be 100% healthy. It will freeze up, it will defreeze in any conditions. If you're moving closer to the maximum particular application, like you are in the mountains, you are just next to a lake which evaporates during winter, so there's much more humidity, much more ice created. You are somewhere in a suburban area when it's really dry, etc. So all these settings you can change. Uh, Questions were about inverter heat modes and their application or implications to noise. and the COP and kilowatt. So we made a table for a 9 kilowatt black, which is the seasonal inverter. Well, there are three general modes you can apply. First is the eco mode, where the machine is limited up to 40%. So instead of 9 kilowatt, you are getting 3 kilowatt. Okay. So always think about that. If you get an eco and a very quiet, it's practically inaudible because the machine runs at 24 decibels. Okay, this is a catalog number. We have the machines here in testing. I have the machine at home. So I can really tell you on the eco mode, it's just super quiet. It's you can't really hear it even if you are one meter away of it. But you need to keep in mind that your actual kilowatt performance is really low. And when I say maximum performance is 3 kilowatt, then think that the normal standard performance you're getting will be 1.5 to 2 kilowatts. So this is really very little heating power you're getting out of the pump in this case. Then the smart mode, that is around 50 to 70%, which you can already hear is some sort of a hum. A boo. You can a little bit hear it, but still very quiet, and it gives you a very decent performance. In this case, 6 kilowatt and a COP of 6, which is excellent still. And then if you are trying to, or if you want to heat up like really quickly, then you would use max or boost or turbo or whatever you might want to call it, which is 100, or in these days, as we see in marketing, and unfortunately we also have to use it, 120% performance. Then the noise level is a standard noise level you would experience with the heat pump. This is up to 55 decibels. I think this is taken at 1 meter. And then you are getting a really full kilowatt performance, and the COP is around 4.5. Last questions that we received were about these new modern marketing campaigns that we have seen about COP20, COP30, COP54, Turbo Boost, 120%, etc. Microwell has been working with brands LG and Midea in the field of air conditioning and house heat pumps for 25 years. We are actually the biggest importer of the stuff into Slovakia and Czech Republic. And we've been doing house heat pumps for how long? 15 years. So we have got quite an experience with these things. And I can tell you that as we speak, we reached maximum technical potential of the machines. Like, you use a twin rotary compressors, you use a DC compressors, you use a BLDC drives, you use DC fans, you use electronic expansion valves, which means you control electronically the amount of expansion. Use all sorts of sensors, and you're trying to make the change in the settings whenever it's possible. We reached the peak of the technology, and this is simply where it is. Any marketing stuff, Turbo Boost, which also we are going to imply because we see the market moving in that way. COP of 20 or anything like that. It's just marketing. It's something you can't achieve in long term. Of course, if I take you to our testing facility, I can show you a COP of 200. That's easy to do for 3 seconds, 5 seconds. You can do it, for example, by turning the heat pump to 100%, keeping it there for 10 minutes so the titanium tubes inside the exchanger are hot. And when that happens, you turn the heat pump off. You just switch it off. So what happens? Your titanium tubes are still hot, and the water flowing around them is still taking the heat from them, but you don't have any power supply, any power consumption from the heat pump. So your COP is generally unlimited. It's free energy. So you can do all these sorts of things with this, or you can turn the compressor off and on, like in very rapid thing, which isn't particularly healthy for a compressor, but you can achieve a COPs of 50 for a fraction of a second or for 3 seconds. So anywhere above 7, 8 COPs, or let's say 10 COPs in this case of a black, while you're getting very little, nominally 3 kilowatt instead of 9. Anything above that is just pure marketing, and it doesn't have any technological background behind it. Maintenance. Heat pump is very easy to maintain. If it's correctly installed, you don't really need to do anything. My suggestion is, this is what I always do with the pressure cleaner. I clean from the back every year. And this is the suggestion to do it also from your side, from the leaves or dirt, etc. Otherwise, if you get a split system, optically, visually check if there isn't any oil, any leak, anything like stainy or oily, which doesn't seem to fit into the installation. Materials, we have tons of materials. If you have got nothing to do on Friday evening, then just give me a call and I can give you a really nice booklets of information about heat pumps. But seriously though, we have got really a lot of inputs. If you got any questions, just let us know and we are here to respond with them. Last thing to point are the videos, and oh, sorry, I just jumped through it. Are the videos. So we are continuously enlarging our video section on our webpage, where we're putting all sorts of videos about the product introduction. I don't know, I can see here a black Wi-Fi connection. I can see a remote controller for a dehumidifier, battery change, etc., etc. So please have a look at the video section. If you got any question, maybe you'll find your answer there. Continuously, practically on week base, we are adding videos to this section. So feel free to have a look at that. Click subscribe to our Microwell channel. If there's a new video, you will be popped up automatically. So that's it from my side. That's 57 minutes. I was supposed to do it in about 45. I apologize. This time a little bit longer. Again, this is our small team for export to support you. Myself, Mr. Shosh, and my wife Veronica. They are primarily responsible for export. That's it. I would now cover quickly questions that I see in a Q&A session. Please feel free to ask the questions. I can see them. I think you can't. But I can. So I'll quickly go through the questions and try to finish the presentation in about 2-3 minutes. Yes, we have got the questions. That's the flow switch. Yes, there are questions which were received during my presentation about the flow switch and bypass valves. I think I responded all of them during presentation because, as I can see from the time of the question, you wrote it during the presentation. So everything was answered. Once again, this webinar is being recorded, so we will publish it again on our Microwell YouTube channel and the webpage. You can have a look also afterwards. You can give it to your service people and try to see for yourself afterwards. Yes, there's a question about the Modbus or RS485 connection. Yes, every single heat pump that we do, it's a black inverter, green inverter pro, Inventor or Premium. Also from next year, already probably from fourth quarter this year, also dehumidifiers will have RS485 port. So every single machine has RS485 serial port. We work with Modbus protocol. Okay, this is very important, Modbus. You can use a lock zone, for example, for it, and you just connect it to a converter and gateway, and then we have all communication protocols for every single PCB, every single machine with us. So if you need the Modbus protocol for a particular machine, please let us know the serial number. Ideally, not ideally, is at least the machine that it's Green Inverter Pro 1500. but ideally a serial number, and then I can send you an Excel file with Modbus protocol that you can see all parameters and all programming for read and write. So you can generally read all the data that the PCB reads much more than the display offers you, and you can write the data. Again, on the write data, we suggest our distributors to try not to play with system settings such as hertz of the compressors, expansion valve, etc. Because with these Modbus programming, you are able to change generally anything with the machine. So we tried really to focus on the water temperature and heating and cooling cycle, etc., etc. Yes, another question to Wi-Fi. That is the timers. Yes, we do receive these questions about the timers and the Wi-Fi. Well, the timers usually are there to limit the pump in certain hours. If you want to limit the pump in certain hours, it's better to do it via filtration. If you are 100% decided that, okay, I only want my pump to run certain hours, keep in mind that you may not reach your desired water temperature, because if the heat loss is bigger and your pump doesn't have time, it will simply not heat the water. So you can use either the master connection, which is, let's say, the Modbus. You can use the filtration clock. We suggest, however, that your pump is connected directly with the filtration, so the pump should be able to control it when it needs. So in this case, when you have it like this, you got to set up a timer. The timer you can set up even either via Wi-Fi application or directly on the display. I need to say that on the display, it's kind of old-fashioned. You need to, put the clicks and the numbers, etc., but still doable with the manual. Wi-Fi is pretty easy to do. Yes, a question about, yes, the apps. Yes, we published or we merged all possible apps into a smart life. So there is a new application, or new application. I mean, this was done in 23, a year and a half ago. Generally, all applications that are available are or have been merged to Smart Life. So we have got instructions how to connect it. This is also in the manuals already, and we also published blog on our website saying this. This was sometimes back in 2022. Yes, I got another question here from Adi. Some pool constructors are complaining if the heat pump is turned on by the temperature request of the heat pump and not by the filtration system. Then the heat pump will influence the filtration setup. What's doing wrong in this case? No. If the heat pump, you got two options. First of all, to connect hydraulically the heat pump. First option is to connect it to existing filtration circuit. Second option is to connect it individually. So you got your filtration circuit, and then you got your heat pump with circulation pump, which only is there for heating. Your question is about the setup with filtration, so with everything. Yes, in this case, if normally in the summer you would filter, let's say 12 hours, maybe 16 if it's needed, but let's say 12 hours is a number we can work with. It is possible that during these 12 hours, the heat pump is off, your filtration cycle goes through, and then after the filtration cycle has been finished, your heat pump says, okay, I need to heat up or I need to cool down, whatever. So in that case, your heat pump will turn the filtration and your circuit will go through filtration. Yes, that is correct. So this is what happens. This is how it works. I have no real arguments why this should be bad for the pool or filtration. I mean, if the water was filtered before and was clean before, then you are just going to recirculate the clean water. So there isn't any issue about that. Okay, I got another questions about the R290 propan gas. Yes, there is a new directive from the European Union, which came into effect this year. It's quite dramatic when it comes to heat pumps. It generally forbids R32 as a gas. So when we had R410, R407, R42, R32, that is gone. So from 1st January 27, most likely, I'm saying, because still there are some questions to answer. Most likely all pumps will work on propan R290. We already have some samples in the company. We have done some tests. LG and Midea house heat pumps, we already have been selling them for about a year on R290. So the experience is there. We just have to clear the questions with this directive because it isn't 100% clear when it comes to application for pool heat pumps. It very much regards the house heat pumps, but it's not 100% clear about pool heat pumps. So these are the questions to resolve, but we will inform you via newsletter and other things. Okay, it's 6 minutes after the hour. I will close the Q&A session now. If there are any further questions, please feel free to send us an email. We can discuss afterwards. Once again, we will publish this webinar on the YouTube channel. So once again, thank you very much. And let me please, in this summertime, say hello to so many countries I can see that are connected here on this today's webinar, which is amazing. From our Slovakia, we have reached to so many countries. So once again, many thanks. Enjoy the rest of the summer, and we will be back in September with more webinars like this, focused on dehumidifiers and the new directive for the heat pumps and other tips and tricks. Many thanks. Goodbye.